Hello, everybody. Welcome to another edition of Show and Tell Monthly for the August 2025 edition. We did skip July. I'm sorry. I was honestly just too much going on, having such a good time wrapping up Dynacon this year that I just could not pull off doing the live stream. But we're back. We're back. It's August, and we're ready to talk to 3 new creators on their really cool projects and some other fun stuff that's coming up with OSHWA. We do have our up and coming Open Hardware Month. So Open Hardware Month is every October, and that is a great time to celebrate open hardware in any way you possibly can. So things like having events at your makerspace, hanging out with folks, certifying your work. Those are all great ways to celebrate Open Hardware Month. And we'll also be doing some fun stuff on our end. We're still working out the details, but it looks like the extremely long live stream will be back, maybe on slightly different terms. I think we're only going for 12 hours this year, but we will be doing another membership drive live stream. So really looking forward to that this year and getting folks involved. And there's going to be some really fun activities throughout the live stream. If you were able to tune in last year, you probably saw some fun stuff. Fun stuff is going to happen again. Hopefully you're down for it. So keep that in mind as we start moving through this summer, wrapping up and going into the fall. We also have our brand new launched student open hardware fellowship program. So this program will be for folks who are in school in whatever capacity that looks like, and wherever they are, they can participate in the student fellowship program that is geared towards getting them all up to date on the way that open hardware can look and the ways that they can participate, and hopefully developing a project for certification. So if you're interested in that, there will be a link to the application in the description when this is all said and done for. And but today we're going to talk to 3 really rad creators of open source hardware that has been newly certified, and we're going to start with the wonderful Jasmine Liu. So welcome, Jasmine.
Hello, thanks for having me.
Thanks for joining. So Jasmine has created the Facerum smartwatch, which is super cool. One of the coolest wearables I've ever seen in my life. So let's talk about how did this come to fruition?
Yeah, okay, I can share my screen. Oh wait, how do I do this? Okay. Oh, okay. So does this look good?
Yes.
Okay, great. So yes, I'm Jasmine. I'm a PhD candidate at the University of Chicago. So I'm working on my PhD, and this was one of my first projects during my PhD. Yeah, my slime mold smartwatch. So I have these slides because this was actually a paper, but this smartwatch that I also have here. So interrupt me if you want or have specific questions, but this smartwatch that we designed actually has a living organism, a slime mold inside of it, um, which is really fun and weird. But we designed this smartwatch with the idea that it's not a normal smartwatch. You actually have to take care of the slime mold inside the smartwatch in order for it to grow this living wire like that in the corner. And when the living wire is fully grown, heart rate sensor inside the watch is enabled. So the slime mold is working to enable that heart rate sensor, and when you connect the slime mold back in, it's going to enable power to the heart rate sensor. Um, and a fun little thing with that is that, well, okay, I'll talk about it in a second, but this smartwatch was part of a paper that I did, and I'm in a field of research called human computer interaction. So the idea of the paper was just to kind of explore this idea of what if we created a device that you actually had to care for and integrated a living organism inside of it. Um, and yeah, you might be like, why in the world would you do something like that? Um, but we're in my PhD and also for this project, we're really interested in this concept of, or we're interested in how we can reduce electronic waste. So we're kind of trying to provoke this idea of we have all these devices in our world, but with the amount of electronic waste we generate, we're probably not really great caretakers of our devices, or we don't think of ourselves as caretakers of our devices. So we wanted to push that with by designing this device and explore how we could actually become caretakers of our devices instead of just kind of the normal cycles that I'm sure we're all guilty of participating in, where we have a device, it breaks, or we want a new version and we throw out the old one. Um, so yeah, that's like kind of like the overarching motivation of why we did this whole thing. Um, but like as I mentioned, this was part of a research paper, so we kind of had this like wild concept of how we would create this like caring interactions network by putting a living organism inside a device. So we wanted the device to feature a living organism and then have it so that the design meant that the user had to care for it. It was responsible for delivering care instead of just like I push a button and then the organism gets fed. And then also we wanted it so that the organism actually participates in the functioning of the device. So this was like our kind of overarching concept. And then we designed the actual thing. So like I showed, this is what the smartwatch looks like. It's also here. Um, and um, the slime mold that I mentioned, its scientific name is called Physarum polycephalum. It's a really cool little guy. Um, it's safe. It's occurs naturally, or they exist naturally in like kind of wet foresty areas, often on trees. And they're also like a big part of a lot of middle school or high school science kits, teaching people how to like grow and cultivate a living organism. And they're also very safe. So they're not something that usually passes any pathogens to humans. So they're safe to interact with. Um, a really cool part about slime mold, there's like three main things that are really cool about slime mold. One, they're really smart, so they grow towards food sources. So in this case, we feed them oats and water, which is like, the same oats and water that we would eat with oatmeal. Um, so they're really smart about growing towards wherever food is. The second thing that's really cool about them is that you'll see in this very sped up video that when they're like lively, they're this bright yellow color, but then they can dry up. And when they dry up, they're like the slightly more yellow gray color. And when they're dried up, they're actually entering this dormant state. Um, so they can be dormant for like years, and you can actually resuscitate them by giving them more food and water, and then they'll return to this bright yellow, lively color. Um, and then the third really cool part about slime mold is that they're actually electrically conductive. Um, so that's the thing that we used to create our living wire that is part of the device. Um, so just to explain kind of like how this works. Um, so when the slime mold is like well nourished, lively, and growing, the heart rate sensor is enabled in the device. But then when it's dried, because the user, for example, didn't take care of it, it's not going to the wire is not going to grow across. Oops, that video was wrong. So the heart rate sensor would be disabled. But then if you wanted to regrow the wire, the user would just have to apply care again through oats and water, and then the wire could be resuscitated. It could continue to grow across and enable that heart rate sensor again. So we use this like really unique life cycle that the Phi Serum has as part of the design of our smartwatch. And all these like different stages of interaction that I talked about are all based around if the user provides care or not. Um, since this is open source hardware, this is like a very like simplified version of the schematic, which is also on the GitHub where all our design files are. Um, if you can see in yellow, this is where the slime mold wire exists. kind of we use it as if it's like a resistor. When it's grown across, it has like roughly 2 mega ohms of resistance, but it can vary, as I'll show you in a second. And we just connect it to an op amp. So if we can tell that the wire is connected, um, there's enough voltage that is supplied to the heart rate sensor, and we have Arduino code that checks if that's the case, and then um, enables the heart rate sensing to occur, and otherwise that's not enabled. So that's kind of like the basis of how it works, and this is what it looks like. I also have this mess of wires of what it looks like on the inside here. Um, the like parts inside the smartwatch are pretty standard. We also have like a little vibromotor to like remind users to feed and water the slime mold, but otherwise it's like the same. And we connect the circuit to the slime mold wire with these little magnets that you can see are kind of connected here, and then the little acrylic case that we designed um, has magnets on the bottom here, and then it'll just like clip in to the device. So yeah, also like this device was made 3 years ago now. Um, so it was very much like still kind of during COVID. I was doing this all at home. And these are some like fun pictures that I amassed over the time where I was just like playing around, being like, could we actually make a wire that's using slime mold? And designing like all these different systems. I was also like, would the slime mold be okay if I wore it on my wrist and like moved around a bunch? So you can see some like cardboard prototypes of that, testing that. Yeah, and just as like a pitch, all the design files that we ultimately came up with for the watch are open source, recently certified, but like the device itself is still quite bulky. So I would love to continue to revamp it and make it a lot nicer. I think that could be really cool to continue to study too, if it was a lot nicer. So yeah, please hit me up if you would like to uh, help me in reworking the watch. Okay, and then yeah, also as part of the paper, we did various like technical evaluations of the living wire so that it's like, you know, a research paper. But we did a lot of explaining about the different sorts of tests and explorations we did to see how you could actually use a living wire made of slime mold in, you know, like real life, I guess. Um, so that involved like choosing like where could we grow the slime mold, what kind of food it would benefit from eating or like eating, um, the effect of light because slime mold like to grow in darker areas, and then also like on average how fast it would how fast they could form a wire like growing across that channel, and then also the resistance over time. Yeah, so the fun part of this paper was also that we actually gave it to people and had them take care of the watch during their daily life. So we had two phases of the study, a caring phase where you actually had to provide care to the watch, and then reflect on it every day. And then we also asked our participants to neglect the watch for a phase. So they weren't allowed to take care of it, and then they also had to kind of reflect on the experience. Um, this was really fun. I was able to like probe my participants by asking a lot of questions, and they had really fun insights and discussions about their experiences. One of my participants what got sick during the study, so their partner was taking care of them, and they were eating a lot of oatmeal and drinking a lot of water while they were sick, and so their partner started calling her, "My little slime," and then so they reflected on how it was kind of a funny moment where both them and the slime were eating the same thing, and they were both being fed and watered and, like, cared for. Um, And yeah, and then other participants talked about how this sort of caring interaction that they had with their device made it feel like it wasn't a one-way relationship like they have with a lot of the devices they use, but it was more bidirectional because that they took care of the watch and it gave them heart rate sensing as a payback. It was like a bidirectional relationship instead of one way. So yeah, it was like really fun to kind of give this to people and see what they thought. This like weird device that explores this very, very different concept. Yeah, okay, so just to conclude, and then happy to like take questions or discuss more about what I think this watch means or provokes, and then also some like little thoughts about how people maybe can be inspired by it for other open source hardware ideas. Um, so like basically, like I mentioned, we use this to kind of explore the fact that typically electronic devices very easily become e-waste because we don't think of them as something that we take care of and are responsible for. So we designed this watch to make it so that you have to take care of it in order for part of it to work. Um, like and part of this was also exploring the idea of how the way we take care of devices feels very different than the way we take care of other living beings, whether it's our plants or our pets. This is my cat, Luna. So building a sort of device like this will let us explore that concept a little bit more tangibly. Um, yeah. So like I mentioned, this was a paper and project that we published 3 years ago now, and it was kind of fun because like randomly there were moments that it became like kind of viral online, and people were like, wow, I would love to be like, would you love me if I were a slime mold, like would you love me if I were a worm, sort of thing, and a lot of fun discussion online about it, which I think was great because then it like this sort of more provocative concept generates a lot of discussion online and presents these concepts around like e-waste and care, and biotech in really fun and interesting ways. We've also got like a lot of press around it. This was a beautiful magazine spread that someone was commissioned to write, and then some like Sci-Fi Wire wrote a piece on it. And then also recently, just to shout out, someone did a short podcast episode about it called My Little Slime, which was really fun. So if you want to hear more about the study and the project, feel free to like check out those things. And this slide is to provide some context. So, like I mentioned, I'm a PhD student. Um, my PhD thesis is around recomputing electronic waste, and I describe it as different computational methods or interaction design methods to better recycle, repair, reuse, and reduce e-waste. So, like as you can see, this project is part of my overall thesis alongside a lot of other ones. And this is my website if you want to check that out. But really fun to include a kind of provocative piece about the role of technology in our lives as part of my computer science PhD thesis. Um, okay, yeah, and then the last point that I wanted to kind of make is that, yeah, I think open source hardware to explore these kind of crazy ideas is really fun and impactful. Like this maybe is not as like functional as a much larger piece like a SparkFun um, like board or something like that. But it's definitely something that people can use and be inspired by to create like other wacky things that probe at different relationships we have with technology. So yeah, open source projects can also be like that. Yeah, I think that's all, but happy to talk about it more broadly, but also if you see this and have questions, feel free to email me. Very happy to talk about the device. I don't think anyone has built it that I know of, but I would love to help people build versions of this device too. So yeah. Okay.
Thank you so much.
I'm gonna
Juan
stop
did
sharing
say this
if
is amazing,
oh,
and
sorry.
right, it is. It's an amazing project. Like I'm so obsessed with this. The moment I saw it come up and come through uh, database, I was like, oh yes,
Oh, yeah.
this is incredible. And I just realized I literally picked up a copy of that magazine the other day,
Oh my God, amazing.
and I just like flipped through and haven't read it yet. But I was like, I know that spread,
Yeah.
so I will be reading that soon.
Yay.
But yeah, I guess just to conclude, what is your kind of hope to see from folks developing this themselves? What would you like to see happen there?
Yeah. I mean, like, this the watch that you see, like, you can tell it's kind of like 3D printed, it's prototype, and also there's like this bulky battery in the back. I think if people kind of keep exploring with it, having a much sleeker profile that maybe mimics more of a actual smartwatch would be really nice because then we could do, maybe like longer term studies of this that are impacted by the fact that it has to be a bit shorter because it's something that feels a little cumbersome to wear, in addition to having to take care of it.
Yeah,
But also, like, I think this concept of using living wires is really cool, and the device that we have, or the design files and the way we integrate it into a circuit is something that could be used in like a bunch of different devices. So I would love to see people design different things outside of like a smartwatch with that little like
yeah.
module. Yeah.
I also really love that play on like visible tech and like the transparency of being able to see the wire in the way that like so many of our
Yeah.
devices used to be made with transparent things so you could see
Oh
all
my
the
God.
fun
Yeah.
guts inside, and like having it be that you get to like see that wire grow and develop and be present in your
Yeah.
life is such an interesting way to live.
I I just went back to the slide because yeah, originally I wanted to make all of the insides transparent, so I was trying to make a transparent case, but
Yeah.
then 3D printing became easier.
3D printing is complicated. Yeah.
Yeah.
Complicates that situation. Yeah, that'd be really cool to see if someone
Yeah.
can take on that challenge of making it like a fully transparent piece of tech and really honor that like tech history, but also yeah, the impact of seeing the living wire alongside all of the
Otherwise.
regular
Yeah.
wires is, I think it'd be really interesting to see. Yeah, this is an incredible project. I'm really excited to see where it goes next.
Thank you. Thanks for having me too.
Thank you so much for coming on today, Jasmine. It was so great to chat and get to hear more about the watch, and I'm really excited to see other folks make it. Audience, make a cool slime mold watch, maybe? Please? And yeah, thank you so much, Jasmine. We'll talk to you soon. Incredible project. I'm so obsessed with it. Obviously, I'm obsessed with it. I keep talking about it. It's so cool, and I really just, having recently come into my slime mold era where I'm just really fascinated by all the ways that slime mold can exist and what it does, this is perfect timing for me. And I hope for a lot of you too, that you are now also thinking about all the ways that slime mold can exist and be utilized. There's a really good book called Slime Mold in Arts and Architecture that I just started reading that talks about a lot of ways that we can think about slime mold. So maybe that's something you want to get involved with. Next up, we've got the wonderful Chris Dirks, who is joining us all the way from New Zealand to talk about the Auckland Train Tracker. Hey, Chris, how's it going?
Oh, there we go. Hopefully that's working.
Yes.
So yeah, yeah, it's 5:30 in the morning here, so
Good morning.
it's a bit darker
Thank you
than
for waking
radius.
up.
Yeah, no, it's all good. Yeah, so let's see if I get my presentation up. Um, so,
As we know, sharing screens is the hardest part of every talk, every presentation, every time you're
yes,
doing a thing. It's always a different setup, and it's always fun to figure it out.
yeah. So hopefully this works.
I believe.
Oh, there we go. I think that should be working. Hopefully.
I'm not seeing it in our options, unfortunately.
Oh, there we go. Well, I'll have to allow it.
Yes, that helps.
Yeah, it does help when you allow it to actually share the screen. So
There we go.
there we go. There we go. Hopefully that's working now.
Yep, looks great.
So yeah, yeah. Following on from kind of seeing the electronics behind stuff and kind of a bit more of sort of the technical side of things, I've made a train map for my city in New Zealand, Auckland. So yeah, for people who don't know, yeah, we are in the middle of nowhere, down the bottom of the world. Yeah, I don't think people quite realize how far away it is. It's like a 3-hour flight to Australia, and like sort of 15 hours over to the US. So yeah, middle of nowhere. So it's a little about me. So I've been into trains for sort of a long time. Since you got the photo down there of me when I was about sort of 3 years old, and I've always sort of really enjoyed just kind of getting into the nitty gritty and having lots of fun with trains and trams, and so it's not too much of a surprise that I ended up doing stuff about trains. But yeah, it's been a while. I've been rather busy with work the last sort of 5 years, so I haven't spent too much time with it. So yeah, it's it's been a fun project, getting to sort of rekindle some of that stuff. So I got into electronics in high school, doing robotics and stuff, and I was starting to do some custom PCBs. Probably about 10 years ago now when I was in high school. And then I also learnt a lot building a 3D printer. It's a bit of a weird one. People might or might not know. It's TiVo Black Widow. Um, Terrible design for a 3D printer, but I learnt a lot getting it working, spending long hours in my bedroom, going through lots of teething troubles. And then as I got into sort of later into high school and university, um, making circuit boards was just sort of a fun hobby that I did, um, and open sourcing a lot of just on GitHub and having fun. And then more recently, I've been doing a lot of software development work, and so circuit boards have been kind of a fun way. So on the right there is a business card I made, just USB cables and just having fun. And it's really cool how cost effective it is these days to just do custom circuit boards. It means that you can kind of play around with it for sort of hobby projects. So there you go. So part of the reason why I did this is it's been about 10 years in the making, but we're getting our first underground rail line in New Zealand. So this is called the City Rail Link in Auckland. And yeah, it's quite a big deal. And sort of earlier this year, I was kind of thinking that if there's any time I'm going to get around to actually doing this, I might as well do it. Now that the City Rail Link all the stations were public, was all ready to go. So it hasn't quite opened yet. They're still a little bit cagey about when it's going to open, but sometime next year. And so I designed the circuit board to sort of be ready for when that opens. So here's some of the background stuff behind how I actually made this sort of train map for Auckland. You can see a screenshot of the PCB design in the background. So KiCad is lovely, especially version 9 that came out just before I started this project. It's impressive how far it's come. And so I've used that a lot for projects, and it's been great. And especially plugins. So I've maintaining my own plugin for the sort of components at JLC PCB, and there's a lot of other cool plugins as well, which can make manufacturing a lot easier, especially generating files for PCB assembly, not just making the circuit boards itself, but assembling the components onto them, because there's about 150 LEDs on them that are about 1.5, 1.6 millimeters. Yeah, I didn't want to have to solder those by hand. So being able to have PCB manufacturers assemble them for you is really nice. The other thing I wanted to play around with is the ESP32C3, which is RISC-V. So that's an open instruction set on CPU. So it's not ARM, it's not the old sort of Xtalica stuff that ESP32 used to use. It's RISC-V. So you can open source it from top to bottom, and it's really cool to start seeing RISC-V sort of taking hold a little bit in the microcontroller space. So I wanted to play around with that. And then on the software side, I wanted to sort of learn how to use TypeScript and Docker for the backend server, just for some projects that I had coming up where I kind of wanted to learn it, kind of build up some skills for my CV. So yeah, lots of little parts that had to come together for this project, but it's quite fun. So this is the other thing. I made this quite a bit more challenging than it needed to be, but I kind of knew I was taking that on. So this is quite a large circuit board. So it's 25 centimeters by 7 centimeters. So doing a 4-layer circuit board would have added quite a bit to the cost. So I stuck with this 2-layer board. I could have gone with an ESP32 module, which would make this a lot easier and have a lot less components. But doing the little 5 by 5 millimeter chip looks cool, and having all the components, being able to see all the components, and not have it covered under a metal shield, it does look kind of cool. So I spent quite a bit of time routing this. So in particular, out by the quite light near the antenna. So if you can see my mouse there, that antenna trace has to be quite wide to get the 50 ohms impedance. So it's tricky to get a full ESP32 on a 2-layer board, but it can be done. And I've actually been surprised by quite how well it's worked. Surprisingly little noise on the rails and surprisingly little interference between stuff. It's not ideal. Like the crystal out on the right hand side is a little far away from the chip, but it works. And yeah, it's quite nice. Expressive, who make the ESP32 chip, if you have a company email address, will just review your circuits for you, and they're quite nuanced and good feedback, which was quite an interesting thing to get them to have a look at it as well. So yeah, if anyone's designing stuff for the ESP32s, go look it up. It's that they're expressive are quite helpful, which is nice. So the original plan for this, I was just making a few for me and my friends. You know, it was just kind of a small, fun side project. Didn't really think too much about it. I wanted someone to make it, and realized, yeah, it's probably only going to be me who's going to make this. There's a company in the UK making stuff for London Underground and doing some train maps for the US and US cities as well. But yeah, Auckland, we've got like yeah, 1.5 million people. Yeah, no one's going to get around to making this. So thought might as well just make this, and just so I can have it on my desk, and some of my trained nerd friends can have some as well. And yeah, made the first 5 of them, and it went pretty well, and had a lot of fun. And then I started to have this thing, which is that people kept asking me where they could buy them, and more and more people. So the photo here is actually one that I sent over to Slovenia. Person not never been to New Zealand, but you just quite like the design. So yeah, I started to realize that this is maybe a little bigger than I kind of expected. Um, so this I started to make some changes so that I could actually sort of potentially sell this. So one of the early things that I did um, is use the ESP32C3 is a little bit different to the original ESP32 in that it has native USB support. Um, Routing the USB traces is a little bit tricky on 2-layer board, but I was able to get it done. And I used a thing that it's a project, an open source project from um, sort of the home assistance space, so home automation community, and projects like WLED also use it. And so it uses a kind of unusual part of the web standards supported by Chrome called Web Serial. So it allows you to access a serial port from a web browser. And then there's a little sort of standard called Improv Wi-Fi, which is basically just a way of just like sort of a fairly simple standard for sending the name and passwords for Wi-Fi networks over serial. So this enabled people to connect it to their home Wi-Fi networks just using a browser, not having to install anything, not having to recompile anything. They could just connect to it with Chrome and Chrome Edge. Unfortunately, Firefox doesn't support it, but yeah, it's I've sold about 70 of them now, and to a lot of people, kind of sort of elderly people in their 60s. And so far, I've been quite happy. I've not had too many people struggle to use it. So that's been kind of cool. I also kind of learning Docker and playing around with automatic GitHub actions. I wrote rather dodgy code, but it's worked quite well to automatically generate that binary that is needed to do firmware updates. So whenever I make a commit to my GitHub repository with firmware, it will automatically generate the binaries needed, which automatically updates the web page so they can also use the ESP web tools to install new firmware updates. So it's a little bit technical, but it's made it really handy just to do quick firmware updates and have people able to just install it through their browser and not need any other software or anything else. So it just makes it sort of easier. So the other thing I wanted to do when I was kind of thinking about selling this is do open source hardware certification. So yeah, I learned about this through Adafruit a number of years ago. And I moved some of my repositories to GPL3 so I could have all of the firmware, hardware, and stuff all under the same license and kind of make it a little bit easier to manage. Yeah, and also open sourcing it was quite cool. I got some interesting messages from people. One of the interesting ones was a guy from Helsinki, and so there already is. It's not been quite made yet, but I'm having a guy design one for Helsinki that he's been doing, which I'm quite curious to see and get one hopefully. But yeah, it's awesome how this has only been a couple of months and we're already getting forks and different projects spinning off, and I don't know, just awesome. It's quite a lot of fun. So some of the manufacturing stuff, now that I've sort of scaled this project up, been quite interesting. So there's a lovely project called KeyKit, which is a plugin for KiCad that allows you to panelize circuit boards with a whole load of configuration options, and it's really made it a lot easier. So to kind of keep costs down, I put 3 of the train maps into one panel, and use on the left and right, it's got V cuts, so those rails can be snapped off. And KeyKit has been great for that. They've got options to do mouse spikes as well, which is a different way of being able to have rails connected on either side of the circuit board, and doing all the fiducials, all the order numbers for the LCPCB on the side, and the JSON configs are in my GitHub repository if you're curious. But also KeyKit has amazing documentation. It's been great. The other cool one, which I kind of briefly went over before, but it's GLC-PCB Tools. It's an awesome open source plugin for KiCad. And so it generates the BOM files that you need to do component assembly as that CSV file. And then it also generates the CPL files. So those are the files that have like the X, Y, and rotation of every component, which is actually kind of difficult. And it also manages rotating those components. It's not perfect, but it's really handy to be able to kind of send stuff off to JLCPCB and to have those files automatically generated for you straight out of KiCad. And there's no other circuit board software that has that, as far as I'm aware. So one of the other issues I ran into is, and I think a few other people noticed as well, is that addressable LEDs are quite sensitive to moisture. So if the LEDs get moisture in them before going through a reflow oven to solder them, they can crack, especially like the clear lens cracks. And when they crack, they often break internal electronics inside of them, so you have quite high failure rates. So I did quite a bit of reading up on having JLCPCB dry the LEDs before they're assembled on, and so far I haven't had any issues from cracking LEDs, which has been good, because I know other projects where they have sort of, a 5% failure rate. And when you've got 150 addressable LEDs, you could have run into some issues pretty quick. And I don't want to spend all my time trying to rework circuit boards. Yeah, so that's been an interesting one. The other one is factory programming. So getting JLCPCB to program and test the boards. So I wrote a small script which tests just some basic tests of the Wi-Fi chip, but then it also flashes the LEDs from red to green to blue, and so they can check it. And I wrote sort of a little README file, so they can basically asking them to check that all the LEDs turn red and then turn green and turn blue, and that has been even better. So my last batch, I had no failures at all. Some of the early batches I had sort of maybe 1 in 20 or 2 in 20 kind of have maybe been an LED that I had to rework, but doing that has been really good. This is a little bit more of the technical side in here, so kind of yeah, there's been some interesting stuff that I've kind of learned and also want to kind of share for other people going into this. None of this stuff affects whether it works or not, but it's always a thing of optimizing things. So on the first batch of circuit boards, I used for bulk capacitance for the SP32 because the SP32 draws quite a bit of current when it's doing Wi-Fi, especially. Um, I added some bulk capacitors. So I started off with 1206, so that's the size, 1206 100 microfarad capacitors. But they had an annoying problem, which is when you pair them up with a bad USB power supply. So I didn't notice this until kind of quite late on, because the power supply I was working with was fairly high quality, low ripple on the 5 volt for USB. But as soon as I put it with a cheap power supply, you had this really annoying, sort of 18 to 20 kilohertz. People call it coil whine, but it's a capacitor, and it's quite annoying. I couldn't hear it too much, but I've got a flatmate who's in high school, and he could hear it quite a bit, and so I looked for interesting solutions. So for batches 2 through 4, I switched using tantalum capacitors. So you often see them as the yellow capacitors on a circuit board. And they solve the problem. They don't have the coil whine issue, but there are some other downsides. So there is some interesting ethical concerns around coltan mining. So coltan is the sort of precursor to tantalum, and yeah, it's not great. So they also have the other issue as well, which is the tantalum capacitors are a little bit more fragile than the ceramics. The ceramics are pretty robust, and because it's all just an exposed circuit board, yeah, it's fine. I haven't had any issues, but I'd like to switch away from them. So the next batch, I've been kind of testing it, which is moving back to ceramics, but at a smaller size capacitor, so having a few more small capacitors, so that be an 0805 size. And so far, with the testing I've done, it seems that they have a winding issue, but it's at much higher frequency, sort of. Well, I'm not sure exactly, but sort of in the sort of 30 to 40 kilohertz range, so we can't hear it. But yeah, it is also interesting. I've been using Samsung ceramic capacitors for this, but different manufacturers have different acoustical properties, so there's quite a deep dive you can go there. Um, so this is something that I was sort of well aware of, but I think through sort of my contracting work and stuff that I've done, but I think it needs to be a little bit more well known in some of the sort of hobbyist space. Ceramic capacitors, don't trust what it says on the tin. So the first example here, so these are actually the same 1206 100 microfarad capacitors that I was using. They're only 48 microfarad at 3.3 volts and 33 at 5 volts. So yeah, they're a third of what they should be at 5 volts, and about half at 3.3. So you always kind of have to factor that in mind when using ceramics, that yeah, as soon as you add any voltage to them, you're not going to get the capacitance that you think you're getting. And it can be even worse for some of the ones. So these are even smaller 0402s. Yeah, they can be 1/5 at 5 volts, even though they're rated for 6 volts. Yeah, you can have some interesting issues. And so there's a GitHub repo where I've used to generate these graphs for a few projects. So you can check that out if you're curious. The other one I'll only cover this very briefly, but there's been some interesting discussions around decoupling capacitors on the SP32, because generally what the manufacturer recommends, and quite a few manufacturers recommend similar things, which is using like 10 nanofarad, 100 nanofarad, and 1 microfarad, using lots of different size capacitors all in parallel for decoupling power rails. Turns out that's not really the best way to do things anymore. Generally, you should go for the largest capacitance you can get in the smallest package. So for JLCP PCB, or sort of the standard stuff, 0402 capacitors that you can get away with, so they have the low series inductor capacitor. So going for 10 microfarad NO402 turns out to be better. There are some interesting stuff, but anyway, don't assume that the manufacturer's like application schematics are optimal. They'll work, but you can often, figure out some ways to make things better over time. And yeah, this post on Reddit, interesting conversations I had for that one. So, making your own. I'd love to see more of these, and it's not too hard to do. So, if you want to do it, you should check whether your local transport authority has a GTFS. So this is a standard that Google made about 10 years ago. And it's a standard way of getting basic position like latitude and longitude of buses or trains or ferries or cable cars, whatever you got. Most does. So yeah, take a look at your local transport authority, see if they have this available. You often have to apply for it, but yeah, at least in the sort of free that I've got access to, yeah, they just give it out to everyone, which is quite handy. You don't have to do it as complicated as I have. There's ESP32 modules, so they have the CPU chip, the clock, the antenna, all that stuff done for you. Makes life a lot easier. Yeah, you don't have to be like me and make it such a challenge to the routing. And yeah, have fun. If you have any questions about making stuff, my email's on GitHub, so you can contact me through that or through my website as well. But yeah, don't rush it. It does take a while to make things look nice and stuff, but it's a really fun project, and I think it's a lot easier than people might expect. Yeah. So future plans. I haven't submitted this to open hardware stuff yet, but I've just been finishing up the designs for Wellington, which is the capital of New Zealand. The only other proper rail network in New Zealand. And yeah, it's been quite interesting. You can see things a little bit different. We've got interesting curves in the stuff with KiCad's new API that came out with version 9, which allows you to interface with it in like Python. And it allows you to place components with exact, X, Y position, orientation. And yeah, also kind of, this is turning into a little sort of side business for me. So I was thinking about maybe a little departure screen and maybe even taking on Melbourne in Australia, which yeah, they have 220 stations. There's about 45 in Auckland, so it'll be a big project if we want to do that, but it could be cool. But anyway, it's already on GitHub if you want to have a look at it, and I'm going to have it open source, submit it for open source stuff soon, hopefully. And so I think that's it. So,
amazing. This is such a great project. I too am a big train fan, although my train fandom is coming out a little bit differently. A friend and I are working on a Glasgow fanzine right now because the Glasgow Underground is such a delight. But
yeah.
This is such a great project. I really love that it's like the active real-time tracking too. Like that's such a fun way to kind of go beyond how folks have done train trackers so far. And I like that you get to like see the LEDs light up as the train is moving.
Yeah, it's actually cool. Between me starting and finishing, actually, so I turn the brightness down a little bit. Yeah, trains are starting to run in Auckland this morning. There's not that many of them out yet, but it is also like 6 o'clock in the morning. So
yeah, the people are starting to head to work.
Yeah,
it's a wonderful project. I'm really excited to see how it develops in other locations, and the Wellington one looks like it's basically ready to go.
Yeah, there's been some last minute changes because I got quite a bit of feedback that people didn't like the way I'd organized some of the train lines, but yeah, it's pretty close to being done.
Yeah. Amazing. Thank you so much for coming on today and giving folks a rundown. And I'm sure people are going to be keeping track of the next trackers.
Thank you.
Talk to you soon, Chris. Another really rad project. Certification database is so full of really cool things. Y'all are always making such cool stuff. It's really great. It makes my job very easy to be able to be like, okay, I have to pick 3 projects to talk about. And then it's actually, the hard part is picking just 3. Sometimes I feel like I need to just do a live stream for, I guess I am going to be doing it live stream for 12 hours soon. And Neil Thompson did just ask, unfortunately, Chris is now off screen, but did it take long to get proficient in KiCad? As someone who has just recently started learning it, I would say, yeah, a little bit probably. It is a very good tool, and it has, but one of the things that I find very overwhelming about it as someone who's just starting to learn it is that there's so much flexibility. There's so much you can do with it that can feel really intimidating going into it because there's so many ways to interact with it. But there's some really great folks who have done really good tutorials. There's really great folks who are willing to sit down with you and work on it with you, and starting to get used to the format of it, and the hotkeys can really kind of start to streamline the process and make it a little bit more simple to use. And the actual like kind of getting started guide that KiCad has is really useful for really getting to work on it. But also there's a lot of really great folks that are frequently doing KiCad intro sessions where you can learn a bunch of different ways to utilize it. So definitely keep your eyes peeled for sessions like that happening in your area or online, because I personally like really need the hands-on. I learn much better when someone is like kind of showing me the steps and I get to do them myself with some like minor guidance as opposed to just following a guide. So yeah, but I believe in you. We can do it. We can all figure out how to use KiCad. And we still have one more guest today. Oh my god. We are now pulling on Szilard Gal. Hello, Szilard. How are you?
Hello. I'm good. How are you?
Szilard is our very first certification from his. So we are really excited every time we get a new certification from a new place, and it is no different this time around. Getting fresh certifications from new locations is always really exciting. So Szilard is the first Serbian certification we've ever had. So congratulations on getting Serbia on the map.
Thank you very much. I'm very proud to have the first place, and I hope I will have a lot of competition soon.
Yes, yes. Other folks, come on, Serbs. We got to see your numbers go up. We're only at 1. And your project that you certified is the VESA ESP.
Yes, exactly. So I have prepared a small presentation to actually discuss it. Just let me know when you can see my screen.
Yep, you're all set.
Yeah, perfect. So the VESA ESP, so some folks will already know what it is from the name, but basically it is about reviving old monitors. So first of all, who am I? I have been developing hardware products for over 8 years. I started in robotics and did a lot of categories from industrial to consumer products. So all around, I'm mostly focused on hardware, but I also do software as well. It, of course, depends on the project. So my whole portfolio can be viewed on my website as well, and you can see my contact email. So I'm basically to move on to the main part. So what is actually the VESA ESP? So it consists of 5 building blocks. So the first one is the VESA mount. So the VESA mount is basically a standard that is used on most monitors to actually have them be able to hook onto some arms or on the wall. And that is basically a standardized plate that can be screwed onto those monitors using some screws. So that's the first part of the name. And the second part is, of course, the ESP. So here I'm using an ESP32S3, which is the top range. At the time, of course, now we have stronger ones. But when I started this project, I wanted to do something new regarding this VESA mount, and that's why I added VGA. So the VGA came into this whole project as I saw an open source library that supported an ESP and the VGA output. So my first idea was, why not make it VESA compatible? And that is how everything was born. So that is why VGA is here. A lot of people ask, like, why isn't it HDMI? VGA is much more simple, and it is just retro. And that is the main reason. So of course, to bundle everything up, to show something on the screen, you can of course add some graphics into memory and things like that, but to really expand the whole compatibility with some media, some pictures, some more text, you have to use some storage. So what I decided to use is a very easy micro SD card, which can be inserted in, and files can be read. And of course, the main building block is the Magic software, and that is basically the whole five parts of the whole thing. So to move on to the hardware part. So the first thing, which you can actually see it here with me as well. So the first thing was actually the shape of it. So when I started to design this, I used Altium Designer. Basically, what I wanted first is to fit it somehow onto that VESA dimensions. And when I put in the mounting holes, I saw some kind of shape, which became this shape. So I wanted to, with this project, as it is a hobby project that I'm releasing, like a first hobby project that I'm like releasing to the public. The main idea was to experiment a bit. So one of the experiments was mostly the shape, as PCBs always come in very simple shapes. I wanted to do something different. So as you can see with this shape, it is quite funky. And the other experiment which I wanted to do is with the silk screen. I've seen a lot of projects with a lot of different color silk screens and things like that. And I wanted to do my version of that. So for example, on the plate, you can see that it is all over the silk screen. And for people wonder, yes, the manufacturers do request more money for the additional silk screen, as it is basically the silk screen covers more area on the PCB than usual. So those were the two experiments that I wanted to do. I think it came out quite interesting. A lot of people first think it is some butterfly or for some drone, and after seeing the VGA, they get the idea that it is something regarding monitors. So next to the dimensions and the experiments, so what are the main features? So on the top, we can see the SD card, which is using just one line of data. That is the reason, because the ESP32 is using the OP RAM to actually do the VGA stuff. So there is none left basically to have the performance, the full performance on the SD card. Of course, to go with the standards, we are using an USB-C, which powers the whole thing, and of course it is connecting to the ESP. Here I didn't want to use the native USB. I just wanted to have a simple way to program it. The first versions were using TAC Connect, but TAC Connect is not that friendly. You have to buy it. You have to create a programmer for it. So just plugging in a CP2102 USB to TTL converter is the easiest way to do this. So on the other end, of course, the ESP32S3, it has that OP RAM that is used to actually be able to actually control the whole 16-bit color for the VGA. In the center, we have a status LED, which can be used for any kind of status indication. And of course, at the bottom, the most important part is the VGA. So the library, which I will mention a bit later, supports up to 16-bit color. But using all of these resistors here, we are actually getting those colors with some dividers. And that is basically the whole hardware. What I wanted to add onto this board, as looking at it like this, it is very simple. You just plug in some power, load in some code that reads something for SD card, displays it on VGA. It isn't expandable. So that is why I wanted to use some of the GPIOs, as can be seen here on the right, to actually make sure that the user can expand it with some buttons, with some outputs, and even to implement some I2C or some other communication to expand the functionality. Of course, next to that, I put 3.3 and ground pins for any application. And that is the main idea, to give the user a bit more flexibility to add things to this device. As one of the main applications can be, for example, in stores, to display some discounts and things like that, and to have a way to actually control things. Moving on, so here it is how it is actually mounted. So as can be seen on the left screen, I have basically used the VESA mount to mount it on the plate. So the plate here is basically an accessory to the main device, and that is used to make sure that you can actually mount it on the VESA mount and actually leave some space for the other components. So that is why basically there are standoffs, and they are basically making it mechanically possible to mount it with screws and still be able to have the device and everything connected together. So the plate looks something like this. It is just a simple PCB with just graphics, so no electrical connections. And of course, the bottom one is the main PCB. So here we can see that power is coming on the top and the VGA is coming out of the bottom. So most a bit modern monitors have VGA, of course, but they also have USB power. So everything can be powered locally, and there won't be any issue regarding that. So here on the right, we can also see how the plate would look without, of course, the VESA mount. So here's a small GIF, which is quite fast, how it is actually mounted. So you can see that the two boards are mounted with the VESA mount at the end. So it is quite simple, a couple of standoffs, and the basic screws that come with the monitors, and it is easily mounted. So of course it uses M4 screws, so it is quite sturdy, mechanically speaking. And with my testing, there were no issues. So what is the magic software? So a big shout out to BitLooney. He made the main library. He of course made it open source as well. And I used his library mainly to use VGA with the ESP, and that is what inspired the whole project. So next to that, I have added, of course, a couple of examples, which I have included on my GitHub as well. So those are basically to interface the VGA and SD cards directly, as the board only has one data line and some pins are reconfigured. Basically, that example code must be used. And of course, next to that, there are GPIO and other examples as well. So the main idea with this project was to actually make the hardware open source so that people can use it any way they want. But the biggest accent is mostly on the software part. As with VGA, you can basically do anything, display anything. But of course, adding all these GPIOs and SD cards, it makes it much more expandable, and basically you can add any feature that you want. So as mentioned before, so the first Serbian certificate, I'm very proud to have that. And of course, I will make sure that there will be a couple more. I already have spoken with a couple of friends who are challenged to actually get a couple of certificates of their own. So hopefully I will succeed in that. Moving on to the last slide. So this is one of the pages that I designed to actually to finish this slide off. So here on the QR code, which is actually read from the SD card, is displayed, which goes to the website. What I wanted to add, a couple of future plans with this project. I'm planning on taking it somewhere live to actually sell it, probably in some kit or that variant, and we will see what will happen from there.
This is so cool. I really love that there's actually kind of like an interesting through line this week of just the way that folks have been making things that can, I don't know, kind of like Jasmine's thoughts around like tech that we actually think about what's going on with it, where it's going, how we're creating this e-waste, and why we are. Like, there's so many times that people are like, okay, well, I got a new monitor, so I don't need this one anymore. But they're still perfectly good monitors. So this is such a great project to like get people to actually think about the longevity of their tech. Are you currently utilizing it in your own setup?
Yes, I will be utilizing it in a shop. So there I basically will set it up to showcase some discounts and photos of products. So that is the main plan. But as I said, in the future, I'm planning to actually go with crowdfunding or something like that. As I know, with crowdfunding, it is a big thing to have this certificate. So that is another thing as well.
Arian is also very into it because he said when and where can I buy this? So the people are wanting something like this. It's really exciting to see that folks are already really down to get involved and have one of their own.
Yeah, thank you, Arian. So yeah, as I mentioned, it will be definitely available. As I see, I have customers, so it will be available for crowdfunding. I will be sharing that on the website as well. But of course, you can check out the website for any further updates, and of course, if you can collaborate on it as well.
I also really love your the way that you've done the two panels. That there's like a kind of more artful section to like kind of hide but still work with the components. That's such a smart design sense of like trying to use the PCB in more than just holding your components, but also adding some dimension and some space, but keeping it clean.
Yeah. I mean, the main idea was to actually explore all of that funky design of PCBs because with manufacturers you get a lot of flexibility what you want, especially with the cutouts and things like that. As most projects, especially what I work on, consumer, industrial, they're all simple boxes and make it as efficient as possible, as simple as possible. So I wanted to like release a bit of creativity into the silk screen as that is mostly the most flexible way. That is the most thing that doesn't impact it electrically. So that was the main idea, to actually explore a bit what I can build on top of that. So I have seen, of course, I think GLC also supports like a multicolor silk screen, but I haven't done that. I put a simple white. I think it's more than enough. As of course they also request more payment, as it is a lot of silk screen on a simple board.
Yeah, that's the other thing. When you're designing artsy PCBs, suddenly the costs go up really fast.
Of course.
But sometimes it's worth it. It's worth it to have something that is beautiful and functional. Is a really nice way to think about that, of like, you can have it be functional and still look really nice and clean.
Exactly.
So, really excited to see this project get further and be more accessible to folks. I'm sure people are going to be pretty on board when you start looking at crowdfunding options.
Yes, thank you very much.
Thank you so much for coming on today, Szilárd.
Thank you.
We're going to drop us down, and what an incredible show. We got to see so many cool projects today. It was so nice to be able to find out what folks were working on, especially these recent certifications have been really incredible. I think folks are really starting to push the limits of what hardware can be in so many really rad ways. So this has been a really awesome show, and I'm really excited to see what comes through the certification database next week or next month. Ooh. So, if you are sitting on a really cool project, now is the time to consider if it's time to get that certified, because you wouldn't believe how fast a month goes by. And we'll be back again on September 18th at 1 p.m. Eastern, and we will be talking about 3 new certified projects. And again, don't forget, in October, we'll be doing our 12-hour show and tell membership marathon, so you can also tune in for that, and you'll hear about a whole lot of really cool projects during that session. So keep your eyes peeled and have a good day, and go certify something really rad. Talk to y'all next month.